Part 3, the vertical line test. Theorem 1.1, the vertical line test. A graph represents a function if no vertical line intersects it at more than one point. So let's look at some examples. Which of the following relations represent y as a function of x? This is the absolute value function. If I look at this, I know it is a function because I could draw any vertical line, and any vertical line I choose to draw will only hit the graph in one spot. So yes, this is a function by the vertical line test. If I look at this graph right here, this graph is just a bunch of points. Is this one a function? Well, here's a vertical line that only hits the graph once. Here's a vertical line that doesn't hit a graph at all. Here's a vertical line, but that one hits the graph two different places. So 2 points on this graph are -3, 1 and -3, 0. So two input values have different output values. So no, this one is not a function. Which of these ones represent y as a function of x? If I look at this graph right here, we notice that no matter where I draw a vertical line, I'm going to hit the graph only one spot. Any vertical line will only hit the graph one time. The one on the right, I can find a vertical line that hits the graph more than once. For example, that line I drew right there, x equals 1, hits that graph in two different spots. So that same input value of 1 has two different y values or two different output values associated with it. So no, that graph does not represent a function. Let's determine if these relations are functions. The first one is y equals -1. So if y equals -1, no matter what x is, y is always -1. I have a horizontal line. So is this a function of x? The answer is yes. Any vertical line I draw will only hit that graph at exactly one point. If I look at the other one, x equals 3. So if x equals 3, no matter what y is, x is always 3, then I have a vertical line. And yes, there is a vertical line that hits that graph in more than one spot. That is the line itself, x equals 3. That line hits the graph at every point. So no, this one is not a function, where the first one was a function. Let's sketch the graph of 3x minus 2y equals 6 and decide if this is a function. To sketch a graph of a line in this form, I would probably find the intercepts. So if x equals 0, what's y? So if x is 0, I have 3 times 0 minus 2 times y equals 6. 3 times 0 is 0, so I have -2y equals 6. Divide by -2, and I get y is -3. So I have a point at 0, -3. I'm going to graph that right here. Then let's plug in 0 for y. So I have 3x minus 2 times 0 equals 6. And 2 times 0 is 0. So I'm left with 3x equals 6. Divide by 3, and I get x equals 2. So I have a point on the graph at 2, 0. And because this is a line, I can just connect those two dots, and there's my graph. So is this relation a function? Again, here the answer is yes, because any vertical line I draw will only hit the graph at one spot. So any line is a function as long as it's not a vertical line.